So, definition once again, quadratic equation. We talked about this on Tuesday. This is your standard form. Y equals ax squared plus bx plus c. Once again, that's standard form. A, b, and c are coefficients. They're the numbers in front. A is how many x squareds we have. B is how many x's we have. C is whatever the number's left over. This will become more important. Understand that later on. Okay. One of the things that you want to look for, we're always looking for. Okay. When we talked on Tuesday, we talked about one of the most important places on a quadratic is the vertex. It's a very important point. It is the absolute maximum or the absolute minimum, depending on whether it opens up or down. The other places that are also extremely important are our roots or our zeros. We're always looking for our zeros. Where's it equal to 0? What makes it 0? Zeros are extremely important. That's probably the most important thing in all of algebra that you will spend, that we spend an inordinate amount of time trying to find are the zeros. And most of this chapter, to be perfectly honest, are finding the zeros. Okay, finding the solutions. Now, graphically speaking, I have a graph. My zeros are where the graph crosses the x-axis. They're also what makes the equation 0, or the solution of the equation. So, for example, I have x squared minus 4 equals 0. That is graphed right here. That parabola is this one here. If I replace the 0 with y, that's the parabola I get. If I solve this for x, my roots are -2 and 2. That's what makes it 0. That's where it crosses the x-axis, -2 and 2. If I put -2 in here, what do I get? I take -2 and square it, and subtract 4, I get 0. So -2 is a solution. -2 is one of my answers. If I take 2 and plug it in here, 2 squared is 4, 4 minus 4 gives me 0. Those are my answers, yes. Any point where the parabola crosses. So this point here and this point here, those are my zeros, where the parabola and the x-axis cross each other. Okay. Right, and it's entirely possible, and we will see examples later, of where it doesn't cross it twice. Sometimes you have 2 answers, sometimes you have 1, sometimes you have no solution. Nothing will work. That's where the parabola doesn't actually ever cross the x-axis. Okay, that's entirely possible that that doesn't happen, that it doesn't cross. Jamie, knock it off. Okay, questions about this right now? Okay. So, okay, there we go. Okay, so solve by graphing them. Okay, one of the ways to solve a parabola, and I'm going to be perfectly honest with you, this is the least effective way of solving a parabola is by graphing it. Straight lines, not so bad. Parabolas, they're really not that accurate. Okay, solving by graphing is not the most accurate way. So it says graph it, then find the roots. So doing this first one together. What you want to do is you want to make a table. Okay? So if we make a table of values, and I don't have a lot of room, so I'm going to do it over here. So I'm going to do x as 2, 1, 0, -1, and -2. I'm going to find what my y is. And instead of 0, if we set that equal to y, that's how you graph it. Okay, so if I were to graph this one, so what I do, I take x, whatever that is, square it, subtract 1. So when I take 2 and square it, I get, what do I get? 4. -1 gives me 3. When I take 1 and I square it, I get 1. 1 minus 1 is 0. When I take 0 and square it, 0. 0 minus 1 is negative 1. Now, when I take negative 1 and square it, what do I get? Positive 1. 1 minus 1 gives me 0. And I take negative 2 and square it, I get positive 4. 4 minus 2 gives me 3. Plot those x, y points. My graph is a little off. The marker isn't lining up exactly where I want it to draw. Your graph should be more accurate than mine. Where are my zeros? Where does this graph cross the x-axis at? Crosses it here at 1 and here at negative 1. And if you look at our numbers here in our table, 1 and negative 1. When I put 1 into the equation, what did I get? I got 0. When I put negative 1 in the equation, what did I get? I got 0. Those are my zeros. Those are my roots. Those are important places. We're going to spend most of the rest of this chapter trying to find zeros in one way or another. Okay? Those are the important places. Okay. Now, yes? Pretty much that does for everyone. There are other ones, there are other graphs that I might not use those numbers for, but I would tell you if I want you to use other numbers, kind of from the standpoint of sometimes the graphs are shifted over, and so doing those 5 numbers won't actually give you a place where it turns around. And so I would know where that would happen, and I would tell you to use different numbers other than those. Those are pretty much most of the time are going to give you what you need to see. Okay? You're going to have to graph a couple today on your homework. Those numbers will probably get you what you need. What you're going to need to have for sure is you're going to need to have it cross the line. If it doesn't cross the line, add a couple extra numbers on either end, and you should be fine, but start with those. Cross here means cross the x-axis. If your graph doesn't cross the x-axis, doesn't like it comes down but doesn't make it all the way up, the second point doesn't make it all the way up, add a couple extra points to get it to come across it. Okay. Now, this one here, we talked about this yesterday. This is our parent function, our most basic parabola, y equals x squared. Do you remember what that one looked like? Where was the bottom of that graph at? Do you remember from Tuesday? The origin. So it started here at the origin and then went up from there. So where's my 0? My 0's at 0. The origin. My 0 is at x equals 0. My zeros here are at x equals 1 and x equals negative 1. Because it only touches it once. It doesn't cross it, it actually just touches it. That happens sometimes. If the parabola touches it, then you have one answer. If the parabola crosses it at 2 places, you get 2 answers. Right, so remember the other thing we did yesterday, we took this one, x plus whatever, and what do we do? When we subtracted 1, it moved everything down. When we add 1, what does it do? It moves it up. So this one would be, start with it at 1. Does it cross the x-axis anywhere? No. Which would mean there's no solution. There's no answer. Doesn't work. Although, in Algebra 2, we do come up with an answer for that problem. It's imaginary. We have imaginary answers. Okay. Now, told you graphing is not what we like to do for solving. I don't like graphing as a way of finding solutions. It's not accurate. You've got to be really, 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 really good at graphing to have it work well. Basically, if I use graphing as a way of solving a problem, I like to do it on a computer or a calculator and let it do the graphing for me because it'll graph much better than I could ever think I could. Okay? This is a better way of solving them. You cannot do this for every quadratic, but if you ever have just x squared, no other x's other than x squared, you can solve by using square roots. It's a two-step problem. Step number one, get x squared by itself. So for example, on this one here, my first step is to add 75 to both sides. That gives me 3x squared equals 75. I don't know. I can, but I want to get x squared by itself first. This works better. If I divide by 3 first, trust me, this will work better. Okay? So my next step would be to divide by 3 now. Don't do it before. Get it like this first. Get any numbers added, subtracted, moved over, and then divide. Here I want x squared by itself. Divide both sides by 3. And I end up with x squared equals 25. So now that I have x squared by itself, that's my first step. My second step is to take the square root of both sides. What's the square root of x squared? X equals. What's the square? That's half your answer. Plus and minus 5. We have to consider both the positive and negatives when we take our square roots for our answers. Because 5 squared will give me 25, and negative 5 squared will give me 25. So it's plus and minus 5. And if you don't give me both the plus and the minus, you're going to lose points. Okay? Because both of them work. What's the square root of 25? It's 5, but it's also negative 5. Because if I take negative 5 and square it, what do I get? I get 25. If I take 5 and square it, what do I get? I get 25. Both of them are answers.
What is the, okay, so say the 25.
No, I need both. I need both plus and minus. So I actually answered 2 numbers here, didn't I? If you look, what did I do? I have plus 5 and minus 5. Plus and minus 5. I have both answers here. Yes?
What is the 25 was negative?
So you're looking ahead at the next problem, aren't you?
No.
Okay, well then let's look ahead at the next problem.
Okay.
So my first step, get x squared by itself. So my first step on this one would be to subtract 49 from both sides. X squared equals negative 49. Get x squared by itself. Your next step is to take the square root of both sides, right? So I take the square root, and I get x equals... No, because can I take the square root of a negative?
No, but
Is there any number times itself that will be negative? Because a positive times a positive is positive, and negative times a negative is positive. The only way to get a negative is to multiply a negative and a positive, right? So this one is no solution. You can't take the square root of a negative number with what you know right now. You can, when you get to a certain level of math, we actually do that. But for where you're at, if you're trying to take the square root and say, I can't do that, done, no solution. Okay? Solving by square roots is really good. Once again, you can only have x squared. If you have x squared and some other x, you cannot use square roots to solve. We will have to use other methods. We will be learning those other methods in the weeks to come. If you have x squared, get x squared by itself, take the square root of both sides.